So I'm John Flanagan. I'm from Harvard Medical School. The scientific problem that we became interested in already back in the 1990s is how the connections form within the nervous system. And so basically the brain, somewhat like a computer, relies on having a very precise and complex set of connections in order to be able to function. And in the case of the brain, the wires, so to speak, that carry the nerve impulses, the electrical signals, are called axons. And so what has to happen during embryonic development initially is that the axons are going to have to grow out and find their correct targets. And so that is guided by molecules outside the axon that tell them when to grow, when to stop, when to turn left or right. And so when we became involved in this work, really nothing was known at the molecular level about how those processes occur. And so we and other groups at that time began to uncover the molecular mechanisms that are responsible for that process of setting up axonal connections. And so we in particular studied the visual system, which is a great system to study for that kind of phenomenon because it's highly organized. What you need to be able to do to see properly is not just see light or dark, but see all the rich detail of the visual world, to have that come in and be transferred to the brain. So the visual neuronal connections are extremely well organized, and so that's a great system to study. But it also can tell one about the broader principles that are involved in setting up connections generally within the brain. So those molecular principles are very similar for all kinds of neural connections. And so then more recently, after initially coming into this from a perspective of wanting to understand the developmental processes, we've become very interested in processes of disease and how one might be able to repair conditions where one has lost neuronal connections, which can be very devastating conditions, to come in and use those molecular principles, the molecular knowledge, to be able to repair and regenerate neuronal connections. And so that's something that we're very interested in now and actively working on. And I think, although therapeutically those things are not right around the corner, I think it's quite realistic to hope that on a time scale of maybe a decade or so, those are things that are going to be potentially available to apply therapeutically for conditions that at the moment there's really nothing we can do about. Things like spinal cord injuries, stroke, neurodegenerative diseases in the visual system, glaucoma, diabetic retinopathy, various conditions that involve loss of neuronal connections one would like to restore. And so, those are the kind of things that we would like to use the money for from the Champalimaud Foundation, and receiving that funding is just crucial for our work. Without the funding, we can't do anything at all in the lab, and so we're tremendously appreciative of receiving the funding that enables us to do what we do. And tremendously exciting to receive this award. Very unexpected, and very honored to be receiving it, and particularly sharing it with just a tremendous group of other scientists and people who I've seen at scientific meetings for years, and we're all a group of friends, and just a great honor to be receiving this recognition for the field that we have been working on.